All right, students, welcome back. We are now in chapter 3. Chapter 3. And if you'll turn with me to page 76, please. 76. And we are going to look at this function, y equals x squared. So hopefully I was able to get each one of you a cool little custom graph to put in here in your notes section. And we're going to look at y equals x squared because y equals x squared is a parabola. So let's make a table for y equals x squared. If, let's say, x is 0, 0 squared is 0. 1, 1 squared is 1. 2, 2 squared is 4. 3, 3 squared is 9. Okay, let's continue that since I don't have enough room. Negative 1. Negative 1 squared is 1. Negative 2. Negative 2 squared is 4. Negative 3. Negative 3 squared is 9. So I'm going to make my xy axes. Actually, I'm going to put it down here at the bottom. And I'm going to just draw this. 0, 0. 1, 1. 2, 4. 3, 9. Negative 1, 1. Negative 2, 4. Negative 3, 9. So this right here you notice that's not a point. I made it rounded. That right there is a parabola. That's a parabola. And this point right here, this point, that is your vertex. So how do we define vertex? Well, in an upward facing parabola, the vertex is the lowest point. So vertex is lowest point on parabola that opens up. And what if our parabola looked like this? Now that's a vertex. So our vertex would be the highest point on a parabola that opens down. Highest point on a parabola that opens down. All right. Parabola, what is a parabola? Well, it's this u thing. That's a parabola. Y equals x squared is a parabola. Now that's not the only parabola. That is just our parent function. Y equals x squared equals parent function parabola. So when they ask you to compare one parabola to its parent function, you're going to compare a parabola to this. This is your parent function. Now, last piece, axis of symmetry. What does symmetry mean? Well, symmetry means it's the same on both sides. So the axis of symmetry is a line where you have the exact same on both sides. So for here, if I draw a line straight down here, that is our axis of symmetry because this is the exact same. I could just flip it over and it would be this. So it's the same on both sides, meaning this is 3, 9 and this is negative 3, 9. Now, a parabola could shift side to side, up and down. It doesn't mean it's going to be 3, 9, negative 3, 9 every time, but it will be the exact same distance from the axis of symmetry. So no matter where this parabola moves, I'm going to have 1 point at 3 over, and then I'll put it 3 over on this side. Another point's going to be 2 over, so it would be 2 over on that side of the axis of symmetry. So that is your axis of symmetry. Divides your parabola into 2 equal parts. All right, and that's the basic right now. What we're going to do today is we're going to do some functions that make this tighter. So your parabola ends up coming up here, or makes it wider, like that. So we're going to do some parabolas and compare it to the parent function. Okay? All right. So let me pause this for a second. Okay, I'm back. So for these two, they want you to identify the characteristics. So I'm going to list the characteristics for you. You're going to identify the vertex, the axis of symmetry, the domain, which is the x values, and the range, which is the y values. You're going to identify vertex, axis, domain, and range. Okay, so for this one, we have the vertex is -1, 1. So the vertex is -1, 1. The axis of symmetry, well, that happens to be this line right here. So the axis of symmetry is right here on -1. So x equals -1. That's your axis of symmetry. Your axis of symmetry is -1. Your domain, what are your possible x values? Well, can it be 0? Yep. Can it be 1? Yep. Can it be 2? Yep. In fact, this keeps going on forever. So your domain actually includes all x's this way and all x's this way. So your domain is all real numbers. And let me see, how do we write that in the... I forget how to write that cursive R that they were doing. Anyways, it's all real numbers. And then the range, which is your y values. But look, there are no y values down here. There are no y values below this point, which is 1. So y is greater than or equal to 1. Y is greater than or equal to 1. So now get those for this one. Get your vertex, get your axis of symmetry, get your domain, and get your range. All right. Unfortunately, we don't have a lot of practice on those ones, but it would be nice to have a few more. All right, so graph the function and compare it to f of x. So here's this function. So I'm going to do x and y. And here's what we're going to do. Bill Davies did this, and I'm a little hesitant to do it, but we're going to do it. We're going to give it a try. Zach, you're going to love this. He says, do these, don't worry about the tables, do them in your head. So here's what it is. It's 5 times x squared. So if I say, I put my pencil on 0, pen on 0, pencil because it's math. So I say x is 0. 0 squared is 0 times 5 is 0. Okay, got it. 1. 1 squared is 1 times 5 is 5. Okay. 2. 2 squared is 4. 4 times 5 is 20. Oh, so it's way up here. Now it's symmetrical, right? So I'm going to go -1. Since it's symmetrical, I can just, and this is my axis of symmetry, I can just count over 1. So that is y equals 5x squared. Now, let's look at the parent function, because our parent function is y equals x squared. So parent function, if I'm at 0, 0 squared is 0. Okay, 1. 1 squared is 1. 2. 2 squared is 4. 3. 3 squared is 9. Okay, so now I'll do the same on the opposite side. There's our parent function. So the blue is the parent function. And you know that. You just know it's 1, 1, 2, 4, 3, 9. Okay, you could do that without making a table. And what this is this is getting longer. This is called a, so the comparison is our new one, this one. The pencil one is a vertical stretch. Stretching out. Okay, let's look at another one. Let's look at K. So I will give you a little hint. When it's negative, it reflects across the x-axis. So a negative is a sad face. Goes, is a sad face. Positive number, happy face, right? A smile goes up. A negative number is a sad face. So as soon as I see a negative right there, I'm going to put this up high in my graph, my x-axis, because I know that it's going to go down. And now I'm going to go, so when x is 1, 1 times 1 is 1, and then the negative gets attached at the end, so it's -1. So every answer I get is going to then become negative. So I have 2, 2 times 2 is 4, -4. 3, 3 times 3 is 9, -9. Okay, so there is our, so I just did, because this is our axis of symmetry, I just counted over to get my other ones. Okay, and we can check it, because so this is -3. So -3 squared is 9. 9 times negative is -9. So this is our new function right here. And we can compare that to our parent function right here. So what's the comparison? What happens to number 5? It's a reflection across x-axis. Okay. So if you notice, that's also negative. So that's going to be a reflection. That's negative. That's going to be a reflection. So these are going to be reflections plus stretches, right? Oh, a fraction. All right. Now, can we do a fraction in our head? Well, the first thing I see a negative. So since it's a negative, I'm going to go ahead and draw that line. I'm going to draw that line. And now I have -1/5 x. So 0. 0 squared is 0 times -1/5, still 0. Okay. Let's go to 1. 1 squared is 1 times -1/5, -1/5. Okay, let's go to 2. So this is our modified one. So 2 squared is 4 times 1/5. 4 times 1/5 is -4/5. 3, 9. So it would be 9/5. Let's see, 9/5, that's almost 2. So -9/5. 4. 16 fifths, that's just over 3. 5. It's 25 fifths, so 25 fifths. So that's 5. So 5 gets us to right there. And I'm going to mirror it. 1, 2, 3, 4, 5. So there's my mirrored. And my parent function goes like this. So what do I have? I have a reflection across the x-axis and a vertical shrink. So reflection across x-axis and vertical shrink. So it's, instead of a vertical stretch where it gets longer, it's shrinking. It's getting closer to the x-axis. Okay, there's your examples. Give these 3 and this one a try, and check the homework or worksheet also. All right. Give me any questions that you have. Have a wonderful day.